And welcome back. Now this week we're going to go through a project that I'd started a few weeks ago and I haven't had time to show you the updates, and it's all to do with this PCB here. Now this is a panelised PCB. What does that mean? It means you create more than one actual PCB on a single panel. So these two here, for example, are joined, but I could have had 3 or a block of 4. And I just thought I'd try it out from PCB Way because they offered to let me have a go, basically. So I did. As it happens, it doesn't save me any money. Yeah, all right, we'll come to you in a minute. It didn't save me any money. It would have been cheaper, in fact, to have it as an individual. But when you're doing surface mount assembly, by them that is, then it is advisable to have it as a panel like this so that they can actually do the assembly. If you get a small little PCB, they can't do it, or it's more difficult, let's put it that way. Anyway, we'll be talking a lot more about this in just a second. Just while I've got things hooked up, if you look at the meter over here, that's one of the boards connected, and in fact it's down here. We'll show you that in just a second. It's this one here, but it is all connected up. Now the lowest I can get this board to run at, as the meter shows, is 25.9 microamps when it's in sleep mode. And in fact it doesn't really go up a lot more than that when it wakes up, does its little check, and then goes back to sleep again. Of course it does use an awful lot more when it does its beeping. So yeah, 25, it's all right. I was hoping for a bit better than that. Oh, there, look, when it makes the sound, it really sucks the power out. Anyway, so you've seen it, 25, well 26 now microamps. Well, you can see what it is. It's not bad, and on 3 AA batteries, which is what it will be running on, a little battery pack like this, bolted to the, well, not bolted, just put on the back. Those batteries will run for something like 14 years. Yeah, I wish, but I reckon I'll get a year's worth out of them. Well, it depends how often it goes off, of course, doesn't it? Okay, so this is, if you haven't seen the intro to this whole project, look up there, because that's all about Benny's PIR, where the cat goes into the airing cupboard and gets himself locked in. But before we talk any more about this, and let me clear the decks a little bit, let's have a word from our sponsor who makes this video possible. I want to give a shout out to PCB Way, PCB Prototype the easy way. Just enter the dimensions of your PCB, choose the number of PCBs you want and the layers, and hit the Quote Now button. Here you have options to select just about anything you'd ever want on a PCB. I tend to leave mine on the defaults because it's the quickest shipping option, with green solder mask and white silkscreen. As an example, here's a board that I had made a couple of weeks back. This is a panelised board, but it worked absolutely wonderfully. Here it is when I've partially made up one of the boards. So simple, and a high quality PCB. If you don't fancy making it yourself, you can also go for their assembly process. For the assembly service, you can get 20 pieces for just $30, and you get free shipping thrown in as well. Why don't you have a look at their website and try them out now? So the idea was then that this PCB, this whole project, was going to detect my cat going into a dark cupboard, the airing cupboard, and being locked in there, which has happened a few times now. And so I designed this circuit, which was pretty simple, but it does build upon some of the videos that we've done in the past. For example, first of all, this runs on batteries, so therefore we have to be careful about power supply. So what this does is go into deep sleep mode until the PIR wakes it up. That's connected to an interrupt pin, which is on the ATMega328P, is only pin 2 or 3, so that's connected to one of those. In fact, I've got the circuit diagram on the other monitor, and it says it's connected to pin, can't find it, never mind, it's one of the interrupt pins. Okay, so when this wakes up, because there's been movement, it goes, is it still dark? And if it's dark, it means that the cupboard door is shut, and therefore there's been movement inside a dark cupboard, which invariably means Benny's snuck into there. So it goes, ah yes, it is dark, and there has been movement, therefore I'm going to sound a little alarm, just a little beep beep, so we hear it. If it's light, or light enough anyway, it goes, ah, it's probably somebody opening the cupboard door. I don't need to do anything. I'm just going to go straight back to sleep again until there's further movement detected. And the thing about this little PIR here is that it stays active, if you like, for about 2 seconds, and if there's continued movement, it continues to stay active, which means it won't keep re-triggering the chip. Now that all works very well. I had to make a minor modification to the original circuit because I was bringing the interrupt pin high. Now the 328P does not support that. Well, actually it does, because I was using it but not reliably, or at least it doesn't say it supports it reliably. So to that end I've put a transistor in here so that this triggers the transistor and the transistor brings the pin low. If you look at the circuit diagram, it's simplicity itself. Let's switch over to that. Here we are. So basically this is the PIR unit here, and that triggers this transistor here, and the collector on here, it's probably a bit difficult to see on the screen, but it goes all the way back here to physical pin 5 PD3, so that's GPIO 3, and that's what triggers it. So yeah, that's fine. And there's the buzzer and the variable resistor with the LDR down here, and that's about it really. Oh yeah, there's opportunity to put a couple of LEDs in. I haven't used those, I just did it because I could really. Okay, so that's all okay. This was designed using KiCad, by the way. A couple of them decoupling capacitors, the battery, and that's pretty much about it. Oh yes, of course, this does monitor the battery supply, as I mentioned. And so on the AREF, we really need to decouple that to ground with a 0.1 100 nanofarad capacitor. And that's it. I mean, it's a simple little circuit, but as I say, it does use a few of the things that we've done in previous videos, like deep sleep mode, of course. Now in deep sleep, by itself, the actual chip, I can get that down to something like, I think it was 1 microamp, or even below that, 0.2 or 3 microamps. Which is what the data sheet says it will do if there's nothing connected to it at all. But on this one I haven't managed to do that. It's 25 microamps with everything connected, and I guess, I don't know, leakage current maybe, just, you know, a few microamps here or there. What's a few microamps between friends anyway? So the idea was then, I built it up, so this is the original prototype, and I was going to connect it to this 3 AA battery pack, which as you see, the holes on the PCB all align with the PCB, with the battery pack PCB holes, and you can just about make out they do align somewhere. And I thought, this is great. I mean, my measuring skills met my expectations, and all this was going to fit into this little box here. As you can see, it all looks pretty good. There's the adjustment for that. So it's facing this way out. There's the hole so we can hear the beeper. There's a hanging hole to put a screw in the wall or something like that. And there's the PIR down there. So all perfect, wasn't it? What I designed is what I got. Yes, all right. It didn't work out quite like that, because in my excitement about getting all this measured and drilled and everything else, I forgot that there's 3 dimensions to this project, isn't there? As well as getting this board to fit inside there, which it did perfectly, the depth of this, so the battery pack plus that beeper plus, would you believe, this chip in a holder plus these pins, which were originally pointing vertically, straight up in other words, and these, well, I'm afraid it just didn't fit in here. So let's have a look. Let's take the lid off this, which we will do, and see what amendments I had to make. Right, let's take the back off. It sort of clips in on those little 4 things on the side, so it's easy to get off. He said, fumbling. Right, that's off. So there's the circuit board, and it looks pretty similar to this one, doesn't it? But there are quite a few changes. One, the chip is now soldered directly onto the PCB, no socket because it made it too high. The buzzer is now a passive buzzer, not an active one like that, because my passive buzzers, you probably can't quite make it out on video, but it's smaller, it's lower. That's the whole point. It's not so tall, so therefore it fits behind the back panel. That's okay. Yeah, these pins have been replaced with right-angled header pins. And yeah, the biggest problem with this whole design is that I made a major boo-boo on the design. I did not allow for an ESP programming socket. What's an ESP programming socket, you ask? Well, a lot of you, of course, will know that every Arduino has got one, and indeed Nano as well. Let me show you. So here's an Arduino clone, and here, ISCP, that's wrong, it should be ICSP, in-circuit serial programmer. It's just 6 pins, and on these 6 pins you've got positive supply, VCC, you've got ground, you've got interrupt, you've got MOSI, you've got MISO and S-clock. Right, so you've got 6 pins here, and I've used these many times programming Arduino, so I don't have to go through the USB. But on this design, I didn't allow any way to program it. Basically, because I thought, well, I can program it offline on this little board here, which works wonderfully well, I might add. Really good, and we've been through that. I know it's upside down, but it's an open smart shield that plugs on top of any standard Uno. That works great, including writing bootloaders and all that to it. And it would have worked okay-ish here, except you've got to remember that even if you program this on that programming board, you put it in here, you do a few bits and pieces, you play about it, you go, it's not quite right, I need to make a very little subtle amendment to the code one way or the other. You think, oh, now I've got to dig it out of here, which, okay, you do once and it's fine, you do second time, it's fine. By the time you've dug it out of here 10 times on the trot, it's all too easy to, well, to bend the pins. Not that I would, yeah, all right, I did. I bent one of the pins, right, because I was using my chip extractor tool, which looks like this. This thing here, you're supposed to put it at each end like that, and as you squeeze, there's these little hooks basically retract and pull the chip up. It works great with 80 tiny 85s, I can tell you, and 741 op amps, but on this one it wasn't that great, so I ended up reverting to the tried and trusted method of using a screwdriver, where you get a screwdriver like this and just sort of lever it under one end and sort of wiggle it so it just comes up a little bit, and then you do the other end, except by then this was in the way. So all in all, it was a big PITA, and eventually I ended up bending one of the pins, and it was just pure luck that it didn't snap off, and I actually needed that one that's bent. Whatever the case, it was a real pain to do, and if I'd put in one of those ICSP sockets on here somewhere, and let's face it, there's plenty of room, I could have put it here or something. I made it right angle so it didn't point up into the sky. I could have then used my serial programmer with this cable plugged into there and the other end plugged into here, and it would have made life a whole lot easier. I mean, really easier. So I've learnt my lesson. What I had to do then to work around that, of course, was actually connect to the individual pins that I needed, the plus, VCC basically, MOSI, MISO, S-clock, and ground. Did I say ground? Yeah, ground as well. And of course there's the ground. I had to use one of those pins. And it was, yeah, it works fine. I can now program this no trouble at all. But it is, as you can see on this other board that I'm doing, it's just terribly messy, isn't it? Look at all the wires everywhere. So these are the programming pins. And these ones here, well, there's only two actually. There's the TX pin that I'm using. It's that one there. And ground for this, just so I can get some data back from it. Otherwise you don't know what you're doing. So lessons learned then. 1. Always include an ICSP socket so you can program it whilst it's in circuit. And secondly, always make sure you have the TX pin and ground pin somewhere reasonably accessible so you can connect one of these things up and get your serial.print statements back out. Yeah, the lessons we learn, eh? Well, the lessons I learn. You guys are probably ahead of the game. So anyway, apart from the inconvenience of programming it in this funny old manner, but once you connected it up, it's all right. It's, you know, you connected it up, it's connected up, isn't it? Yeah, it's okay. And the actual circuit and board and stuff was absolutely fine. no trouble at all. These caps, these 100 nanofarad decoupling capacitors that you have to put really close to the actual VCC and ground on both sides. So this is the analog power supply, this is the digital power supply, that's the AREF, that one. So the 100 nanofarads, they were actually a bit big for the footprint that I'd used. So I had to sort of really scrunch them in a bit. That's another lesson learned, make sure the footprint manages the components that you've actually got. Yes. Apart from that, oh yes, one final thing. I had to replace this big, fat, chunky, active buzzer. The active one being, where's the active one? Oh, I haven't got it on here anymore. This has already been replaced. So what's an active buzzer? An active buzzer is where you can just supply plus 5 volts and it beeps straight away. So if you connect the 5 volts to one of the GPIO pins, you can make it pulse just by, making it high, delay, low, like an LED flasher basically, but instead of an LED flashing, this just goes beep, beep, beep. And I thought, oh, for simplicity, that'll be all right. But as I say, it was too high, so I've had to replace this now because it's got a little blue blob on there, like I put on there. It's a passive one now. The passive one, as you can possibly tell, no, the lighting isn't that great on here. The pins weren't quite in the same position. The mounting pins on here were something like 6.5 mil apart, and the original ones were something like 7.5 mil apart, of that ilk. I don't know if that's totally accurate, but let's put it this way, it wasn't just a drop-in replacement. I had to sort of force it in and hold it in while I was soldering it. Luckily for me, the passive ones work only by connecting it to a pulse width modulated pin, and this was, I think I did that deliberately actually as part of the design, he said. No, I did. I'm pretty sure I mentioned that in the previous video as well. So luckily I could drive this then using the Arduino TONE command. So you just say tone, pin 5, frequency of 2000 kilohertz. No, 2000 hertz. Let's get it right. And I want a tone for 1 second. And it just does it. Basically generates a PWM file. Signal out to it, and you can either do it manually or use the tone command. As I say, it might as well use the tone command as it's there. So that now makes that tone that you probably heard right at the beginning of this video, and any other tone you care to put out. It's not hugely loud, but I think it's loud enough. I'd hear it, if Benny got trapped in the airing cupboard again, I'd certainly hear it. Now the one you actually heard, funnily enough, was not an airing cupboard one at all, because this is a sort of it's a chip on a board, isn't it, with a few holes for components. A friend of mine, he's got a fridge. Yeah, all right, so have lots of other people I know, but his fridge, it's a Siemens fridge, casting no aspersions here, but he's got the most ridiculous design of the interior light. Every fridge in the world that I know, when you open the door, the light comes on. When you shut the door, the light goes off, right? And there's a little toggle switch somewhere on the frame, isn't there, that does that. Who knows, maybe super duper fridges have some kind of hall device, magnetic device that turns it off. But whatever, you shut the door, the light goes off. In this guy's fridge, there's a little switch. And the switch does not turn the light off permanently, so you can just say, I don't want the light ever to come on. No, it turns the light on permanently. And the switch is in a place where you could easily put, a jar in there and knock the switch, and the light is on permanently. And you don't know, of course, because you open the door, the light's on, which you expect. You shut the door, you assume the light's going off, but in fact it stays on. What a weird design. As I said to him, I think that's a Friday afternoon job. Somebody's connected something up the wrong way. Why would you want the light on all the time? It just doesn't make sense. I could understand switching the light off permanently for whatever reason, but not switching it on permanently. And of course it was an incandescent bulb as well. So it generates heat. It's only a 15 watt bulb, but it's 15 watts of heat going into that fridge. No wonder it is trunching away and making the ice on the side of the freezer unit go mad. So he's replaced that now with an LED bulb, so there's no heat. And I said, I'll make you one of these, a variant of these, that tells you if you've left the light on, knocked the switch. So that's what this one does, because the circuit allows that, doesn't it? All I've done on this one is remove the PIR and associated components because we're not interested about movement. What this one does is simply detect the light level, and after, well, an arbitrary amount of time, but I've said a minute. If the light's still on after a minute, that's a long time to have your fridge door open. It will in fact sound a little tune that you heard. And what this does, this goes into deep sleep mode, but it's not woken by an interrupt like that one. It's woken up by the watchdog timer. Now, we did a video on this, and this is a practical implementation of it. What happens on here is that you put the device to sleep but run the watchdog timer. What's the watchdog timer, Ralph? Glad you asked. Your watchdog timer, which most people do not have switched on their Arduinos because, well, they probably don't know how to use it, quite honestly. But what the watchdog timer is, as the name implies, it's watching. It's a watchdog on the chip. And in your code, you would normally say, every iteration of that loop, you'd say, watchdog timer, everything's okay. Just reset, reset, reset. All the time. Doesn't matter if you do it 1,000 times a second, as long as you're resetting that watchdog timer, which is an independent part of the chip, cannot be controlled by anything, you can just reset it. Now, what happens if your program hangs? Oh, all the code stops. The watchdog timer, an independent part of that chip, suddenly goes, hang on a minute, you haven't reset me. I've reached now the maximum that you've told me to reach, which is as short as something like 62.5 milliseconds and as long as 8 seconds. It goes, whoa, you haven't reset me. I'm rebooting your board. Now, in this case, of course, we don't want the board rebooted, thank you very much. We just want the watchdog timer to say, oi, your 8 seconds are up, because I've set it to the longest I could do on here. So as the watchdog timer says, oi, I'm going to reboot you, it actually jumps into a bit of code, an ISR, interrupt service routine. And it says, right, I'm in the interrupt service routine. You can run a tiny bit of code here if you really want to, but then I'm going to reboot you. But what you can say at that point is, oh, no, it's okay. Don't do anything. Thank you very much. So every 8 seconds, it can come into that routine. You go, okay, thank you. You've let me know. Don't do anything. Just continue running. So on here, every 8 seconds, it jumps into that interrupt routine and goes, oi, wake up. So the circuit from deep sleep, because it's doing nothing at that point, and certainly not resetting the watchdog timer, wakes up as a result of that watchdog timer prodding it. The circuit, the program that I'm running then, of course, says, okay, don't do anything. I'll just continue running, coming out of sleep now. Checks the light level using the LDR at the top and goes, oh, still dark. I'll go back to sleep. And then 8 seconds later, the watchdog timer jumps in and says, oi. Okay, you get the idea. Now, there's a video all about this, how to use it. Yeah, and that was theory. This is now practical implementation. Now, if I turn on the power supply, you'll see how it works. Right, now, I don't know. Well, let's hope that tune isn't bloody copyrighted. I'll tell you, it's not exactly the tune. I must add, it's a little bit off key. So maybe I'll get away with it. So what's happening now is that every 8 seconds, this is waking up and checking the light level. And after 8 wake-ups, or I think it might be 7 wake-ups now, it goes, well, I've been awake on the trot 7 times, which means the light has been on permanently 7 times. Every time I've woken up, the light's been on. I'm going to sound that tune. And hopefully, even with a closed door and that light on, due to that funny switch arrangement, he'll hear that and alert him to the fact. Now, of course, you could put this in your own fridge. If you don't shut the door correctly on a fridge, big problem with kids, they grab something out, just give the door a push and then it doesn't shut properly. The light stays on. Well, this would be a good way of detecting that. And as I showed you right at the beginning of the program, this takes 25 microamps when it's just in deep sleep mode. So for 8 seconds it's in deep sleep. Watchdog timer kicks it alert, but then it doesn't use that much more while it's doing that. The checking, the reading of the LDR and everything is all done within a few microseconds really. And even better, I think I told you this before in a previous video, the power that supplies that LDR via this resistor here is actually supplied from one of the GPIO pins as well. So there's no power flowing through this bit of the circuit, the LDR and the variable resistor here, until this wakes up. So on wake up, it goes, oh, switch on that bit of the circuit so power runs through it. Now read how light it is. No, it's dark, that's fine. Switch it all back off again, go back to sleep. Now what I have discovered is that there is a very strict order in sending your chip to sleep. You can't just do it any old willy-nilly. I'm just going to turn the power off here. You can't do it in any old order. And the circuit sketch that I'm using for this fridge alarm looks like this. Right, this is the entire sketch, but I'm not going to walk you through that at all. I'll put it up on the GitHub if you want to have a look at it. There will be a link down below because we've done this sort of thing before. But so the full sketch will be up there. What I'm going to talk you through very, very quickly is the going to sleep bit. All right. Oh, you can see there, by the way, this is an excellent program. I recommend this one. I'll put a link up there for that as well, if I remember. This is called CoolTerm, CoolTerm, CoolTerm. Yeah, all right, we've had enough now. Do you know, I've put some blue tack over the beeper hole. It's actually made it louder. I don't know what's going on. So let's just switch that off for now. You've seen the output here. Yeah, so let's have a look at the code then. So this is the code. I'm not interested. You can have a look at all this in your own time. But the bit we want to look at is the go to sleep bit. Right, this is the, you know, I'm definitely going to go into deep sleep mode. So I've numbered the steps that you have to do. So we turn off all output pins. I'm not totally sure this gives a huge saving, but apparently it's supposed to give you some. Number 2, we disable the analog to digital conversion, but of course first of all we make sure we keep a record of what the setting was. Now number 3 is, and this really isn't applicable in this case, it says you can do some power reduction stuff, but that there's lots of options for that. If you look on Google, you'll find all the listings that you can have for that power disable thing, but it only works when the program's running, not when it's in deep sleep. So I've removed that. We then have to tell it how long we want it to go to sleep for, and that's what this bit over here does. It says go to sleep for 8 seconds and enable the watchdog. We then here we reset the watchdog just in case anything's happening. We don't want the watchdog to reset the board at this instant while we're doing all this. We're telling it what sort of sleep mode we're going into, and I'm going, the only realistic one to save the power is to go into power down mode. So that's what that is doing. So basically switch everything off. Nothing runs at all, not even the clock, nothing. So delays and the millis and all that don't work, of course, in deep sleep. We then say do not have any interrupts while we're doing this. We're enabling sleep mode now so that it can go to sleep. We're disabling the brownout detector. That's the bit where it detects if the voltage to the chip has gone too low. Now I'm not even sure that I've got that switched on this chip because it's all controlled by fuses, which you can set as part of the bootloader. But I've put it in just in case I haven't set it, but it'd be better to set it as part of the fuses. If you're not interested in brownout detection at all, set it in the fuses. If you want brownout detection normally, but not of course while we're asleep, then do it this way. We then, just before we go to sleep, we allow interrupts and then we go to sleep. That's the actual command, sleep CPU, and that's the actual bit of code it executes. So I've just been trying a couple of different things out. So that's it. So then it goes to sleep at that point and everything suspends at that point. Nothing happens at all. Everything's powered down. The clock stops running. Your power consumption drops like a stone, as we saw, to 25 microamps. Nothing happens. Now, if we were on an interrupt-based wake up, it would stay like that until it got woken up by somebody pressing a button or something happening, or in my case, the PIR detecting something and prodding it awake. But in this case, we've got the watchdog timer running. So after 8 seconds, the interrupt, so it won't come to here initially. What it does, it jumps into the interrupt here. All right. And what we're saying is disable the watchdog. So it says, I'm going to reset your... Oh, no, I'm not now. That's it. Then it does continue with the very next statement. So it'll now be here. So it says, now I'm awake. And we're saying, sleep disable. I don't know what that says, de-sleep. I think that's just a spelling mistake actually. Right, sleep disable, and what that actually executes is this here, because it is a macro, it's just a substitution. So I've been trying it out, as I say. So it says don't go back to sleep again, because we've just woken up, we don't want to go back to sleep again. Restore the analog to digital conversion, set all your power pins out again to whatever they should be. And I was originally going to have this power all enabled, but as I say, because we didn't disable it in the first place, because it doesn't matter in deep sleep, doesn't happen in deep sleep, I've turned that off as well. And that's it. So those are the steps that you have to do in those order. Now I had them in different order, and I was getting something like 200 microamps, and I go, well, I know that's not right, so what is it I've done wrong? And I had to go through very carefully, looking at the data sheet and the ATMEL spec and all that, about which order you have to do these things in. And I got it into this one, and it went down to 25. Now I was hoping to get it down to lower than that, as I said, but 25 will have to do, and that's it. Anyway, as I say, I'll put the rest of this this code onto the GitHub. You can have a look at it, make your own fridge alarm if you want to. It's fairly cheap, isn't it? That PCB design, by the way, this one from PCB Way, there's an option on their website to say make this public or something like that, or share it, which I haven't done yet, I must admit, an oversight. So I'll make this public, and of course I do have a couple to give away. So if you want a ready-made PCB, as I say, I've got them like this. I've still got I think I've got 4 of these panels left. So I can just, all these panels, when they're made like this, it's what's known as V-scoring. So you probably, you might be able to just tell there that they've been scored along those lines. So what happens is they snap. There, you can see it going, look, snap. And these edge rails, which I had to put in, well, they put in for me actually, they snap off as well, but I can't do that with a thumb. It's just too narrow. I haven't got the leverage. I have to use that with a small pair of pliers, and that just snaps off exactly the same. And then you end up with a board. So I've got some of these spare. So if you want one, send me an email. It's on the About tab of my channel. The first few people that get picked out of the hat will get one, because I don't think I'll be making too many more of these. I might make another one for the chap up the road, because he gets his cat stuck in the kitchen cupboard as well. And that's about it really. The components are all standard components. I do have a reset button on here. I think that's probably important as well. That's one thing I didn't forget. But as I say, you must program your chip either like this, which is a bit faffy, but it works, or do it all on here until it's absolutely spot on, and then put it onto your board. But as I say, in future I will not be forgetting those that ICSP header, nor the debugging header as I call it, but basically it's the serial output. You don't need all the pins. If you don't need to power it via this, and that's why you can see 2 of these wires not connected to anything. That's the RX and the, what's the other one? VCC. Because I'm not sending data down here, I'm just receiving it from that serial.print. Right, okay, that's probably all we got time for today. This, luckily now, all does fit in here very nicely indeed. I haven't screwed the battery pack onto the back of this thing here. If I take this out, so what I've done this, that this pulls out, that comes out like that. This then just literally falls out. The battery pack I've stuck on the back with these double-sided sticky pads, which quite frankly I don't expect to last more than 6 months before they fall off. But it doesn't matter, does it? It just holds it in there by gravity, really. So that's it. If you think I'm going to try and put that back while I'm on camera, forget it, because it's no, I can't. You need binocular vision to do that, and I can't do it on camera. But it all fits rather well. I'm quite pleased with that, and that just snaps in. Oh yeah, so I had to make a small little cutout here, because this has got a little shoulder on it. Okay, these things you only find out at the last minute, but it's brilliant. It works. And this, now I've done the video, can go hanging back up in the airing cupboard, and Benny will be safe. Hooray! Right, that's it. I'll put links down to PCBU and everything else. Thanks to them for allowing me to make some PCBs and show you guys. Hope you liked the video. Don't forget to give it a thumbs up if you think you liked it, because YouTube needs to know that. And comments down below, please. I'm really looking forward to all your comments, one way or the other, questions, observations, whatever you like. And yeah, see you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.